start by introducing the rest of the technical team that's here today. On the far left, walking up, is Kunal Bajaj. He's one of our technical architects. Chris Henson, who is our lead technical architect, and Keith Noss on the end, who's also a technical architect. Most of what we're going to talk about today, like I said, is focused on some applications we wrote back in 2007. All of the applications used various JBoss technologies, such as JBoss Scene. So, what's that? Oh, I'm sorry. Yeah. Real quick, here's our overall plan. We're going to give you a quick introduction to BigLots, who we are, what we do. It does play a role in some of the technical design decisions we had to make for the application. We're then going to talk a little bit more about the project itself, some of the constraints. We're going to give you a quick demo, hopefully, if everything goes well. Demo is always a little risky. We'll talk through some of the technical choices we've made along the way. And then we're going to spend most of our time discussing some of the technical patterns we came up with as we were going through the development on the project. I'm going to make a couple assumptions here about the who's in the audience. We're basically assuming some basic familiarity with some of the JBoss technologies, such as Scene. We're also assuming some basic JSF functionality skills as well. It's based on, like I said, early to mid 2007 technologies. So some of the issues we faced may no longer exist in the more recent versions of some of the software. We're not going to go into a tremendous amount of technical detail on any one subject. But we're here for the rest of the week. If you have more detailed questions, just track us down. We're going to get, like I said, we're going to give a few demos along the way. And with that, we're going to go on. Real quick, who's BigLots? How many of you have ever been to the stores? Any BigLots store? Wow, that's pretty good, actually. We are a Fortune 500 company. We were founded back in 1967. We do about $4 billion in sales each year. We have stores located nationwide. Currently, we're at around 1,350 stores. The application we're discussing today is currently deployed and in use every single day at approximately 2/3 of our stores as of today. By July, we hope it'll be everywhere. We are a closeout-focused retailer, which presents us certain unique aspects to the retail industry. We face certain problems and unusual situations because of that. Like I said before, some of the aspects about our particular version of retail drove some of the technical decisions we made along the way. So the case study we're here to present is actually part of a multi-year project. You'll hear us potentially use the term MARS. That's the acronym the business chose for the project. So if it slips out and we say MARS, that's what we're referring to. Year one was a complete refresh of the point-of-sale hardware and software. Year two is the focus of today's talk. Year two focused on inventory management software, things like enabling the stores to do inventory counts, transfers, item inquiry, sister store inquiry, those sorts of things. The project was developed by approximately 12 developers over the course of 4 or 5 months. About 2/3 of those developers were Java developers. Everyone else was integrations or legacy developers. The overall application suite consists of about 10 applications. And they were all, like I said before, built on a variety of JBoss related or Web 2.0 technologies, and we'll go through some of that today. Some of our constraints, some of these are probably unique to us and some of these are not so unique. The first one is one of the not so unique. We were faced with pretty tight deadlines on the project, and they were driven partially because of business needs. So we did execute fairly quickly on a lot of this. What we mean by user technology maturity is our typical store employee who's using these applications may or may not be web familiar or web savvy, and may actually not even be computer savvy. So it's an interesting mix of actual users that would be using these applications. The other constraint we run into is we have a fairly small bandwidth between our stores and the central office, and that drove a lot of the technical architecture decisions we made. And finally, from the get-go, we've always had an important need in terms of offline support. No matter what goes wrong, basically we need to make sure the stores can ring sales. And any of the applications we write have to keep that in mind and should degrade gracefully as connectivity, say, to the central office goes down and so on. So, cool. We are now going to attempt real quickly a demo of one of the applications to give you a sort of a flavor of how the applications work and how they feel. And then we're going to switch over to talk about some of the technical choices and some of the patterns we used. So what you see here, over there. Sorry. This is the home page that a typical store manager or store employee would be greeted with once they've actually logged in. They may be doing this on either the back office server, okay, or they could actually potentially be doing it at a point of sale touchscreen as well. There's a menu up at the top which allows them access to the various applications. There's an alert section in the middle towards the top where we can send out important information from the central office to the store employees. And then the majority of the space is taken up by to-do items. These are items that either the central office has sent down and are labeled incoming, in other words, need action, or in the case of the drafts, they are documents that have been started by the store employee but haven't been completed yet. So what we're going to demo real quick is we're going to demo a transfer out. So what's a transfer out? A transfer out is any time a store has a product that needs to be transferred to either another store or a distribution center or something along those lines. So the transfer out in its simplest form is I've got a couple items, and for the demo we're going to say it needs to go to another store. Maybe we're going to transfer the items to a store here in Orlando. Okay? Every application has this template from a listing of the transactions or documents that have taken place. What we're going to do is we're going to create a new transaction. We're going to initiate a store-to-store transfer. And at this point, I don't really know necessarily what the store number is for the Orlando area, so I'm just going to start typing Orlando. So we've got an autocomplete, fills in. Then my method of transport, we'll say truck. Now, typically if I'm a store employee at this point, I've probably done one of two things already. I do have a handheld at my disposal. These items might have very well been sitting here and I've already scanned the items, okay, in which case this list that you see on the right would already be filled in. Okay? So that's one possibility. The other thing we've experienced is the store employees are very good at typing SKUs, stock keeping units, 9-digit numbers in the case of big lots. Okay? So it's quite likely that the store employee knows exactly what SKU numbers and will just rapidly type it, hit enter, and then pick it. In my case, I don't have a particular SKU number. I'm just going to execute a search. So I'm going to press enter. Okay. So what it's done here is it's actually pulled up a list of potential items that have MP somewhere in the search string. You'll notice at the bottom that there's the hint that there are actually more than we were willing to display at this instance, so they can refine their search if they'd like to. I'm going to randomly pick 3 items. I'll fill in the quantities. And at this point, I've got 2 options. If I'm really ready, I could go ahead and submit the document to the central office. Okay? But for the sake of the demo, I'm going to go ahead and save it and return back to the transaction screen. What you notice throughout the demos, we do state that all of the applications have a very similar look and feel. Once the employee got familiar with this overall document lifecycle pattern and the look and feel of the screens, it was really pretty easy to train them on all the other applications. So what you notice here at the top is we now have a draft document. You'll notice the document number hasn't been filled in. At the moment that a store submits a document number, we generate a unique document ID, which is used to track both in the store and in the central office the life cycle of the document itself. So I'm going to go back into it one more time. And this time I'm going to go ahead and submit it. So this is the act of basically the store employee saying, I'm ready to do the transfer. I'd like to let the central office know it. so that they can adjust inventory as appropriate. Did I click it? No. There we go. So they get one chance to look at it one last time, basically a confirmation screen. So what I'm going to do here is I'm going to confirm the submit. And off it goes. So you'll see at the top now our document is in what we call submitted status. Eventually the status will change to posted, which is an acknowledgement that comes back down from the central office. All of the documents, like I said, flow through this common life cycle. The employee can actually go back in and review the document if they'd like to. They have printing capabilities. Almost every one of our documents, I think every document has this capability. The employees can print out reference copies of the document. In the event that there's something that needs to be scanned, we generate barcodes and so on and so on and so on. So, basic PDF capability. So, the main reason I just walked you through that is all of our technical conversations, we thought seeing the application itself will give you good context in terms of what the technical conversations are. And there will be a couple other demos along the way. But at this point, what I'm going to do is I'm going to hand off to Chris Henson. He's our lead technical architect.